In this video, we are going to look at a couple of examples where you are asked not only to sketch a graph of your function, but you are also asked to determine some information about that function as it relates to even, odd, or neither, symmetry, and intervals of increasing, decreasing, and constant places in your graph. So in order to do any of that, the first thing you have to do is you have to be able to identify the parent function that exists inside the function as a whole. So here we are looking at the absolute value of x plus 3. So my parent function is going to be the absolute value of x. Once you determine that, you then can determine any translations you may have. Well, the only translation I have is this plus 3 off the back end. This is an external translation, which means it's vertical. Since I am adding, instead of multiplying, I'm adding a term, this means I am doing what's called a vertical shift. The plus says I'm going to go up, and I'm going up by 3. Okay? And so here what you want to do is, before you do anything else, is you want to go ahead and sketch the graph. Okay? So here we know that we have the parent, and the parent function would start here at the origin, and an absolute value goes up 1 in the diagonal. Since I have to go up 3, I'm going to start and I'm going to shift up 3, so 1, 2, 3. So my graph is actually here, and then it goes up in either direction. So I'm going to go ahead and sketch that real quick. I'm going to use a straight edge just to make it a little bit sharper and clear. Of course, you wouldn't have to do that. You could use just a freehand, or if you're using a internet program like Hawks in order to do your work, obviously that program would sketch it for you, but to do it by hand, you know, there's kind of your rough sketch. So this in itself is f of x equals the absolute value of x plus 3. So now that I have that sketched, I can actually start answering some of the other questions. The first part is you want to determine if it's even, odd, or neither. So in order to determine even, odd, or neither, you have to test it. Okay? So the first thing that you want to do for determining even or odd is we want to insert negative x. So we're going to look at what happens if I look at the f of negative x. So this would be the absolute value of negative x plus 3. When I evaluate my x here, I'm going to end up with the absolute value of x and then plus 3. Since what we end up with is the same as what we started with, we would actually call this to be even. Okay? Now, if we ended up with the exact opposite, 100% opposite, every sign's changed, you started positive, now you're negative, or vice versa, then you would be considered odd. Now, if at any point you do not have an exact identical function or an exact opposite function, then you would be considered as neither. Now the second thing that we needed to look at was its symmetry. So in this case, for its symmetry, we have to look at which axis we have symmetry over. So if I were to fold my graph along this x-axis, I would hope that whatever I had on the top part of the graph is going to match to whatever I have on the bottom part of the graph. In this instance, that would not be the case, because if I were to fold my graph over, what you would notice is that the stuff on the top does not show up on the bottom. Now, if we were to work through your y-axis, then whatever you had on the right-hand side should mirror over to the left-hand side. So if I were to squeeze it up, what you would hope is that these two lines would match up with each other. Okay, and in this case they do, so we call this y-axis symmetry. Okay. Now the very last thing that we wanted to look at was your intervals over increasing and decreasing. So when we're looking at increasing, decreasing, or constant, we have to refer this along the x-axis movement. So what that means is you're going to start on the negative infinity side, and you're going to travel along your x-axis, and what you're looking at is what's happening with your graph. Okay, so in this case I'm going to use a highlighter here. When I'm starting at the most negative side, I would start up here at my arrow, and as I travel along my x-axis, what happens is I'm drawing in a downward motion with my graph. Because I'm doing that, what this actually means is that we are decreasing on this side of my graph. Okay, so this over here is going to be my decreasing piece. Once I get to my y-axis, notice I change direction. So as I continue going around my x here, I change direction and I start going in an upward direction. Okay, what this means is that on this side of my graph we are increasing. So I have to look at the intervals over which that is happening. So if we look at my decreasing, I'm going to decrease along my x-axis all the way until I get to 0. So here my decreasing interval is going to start at negative infinity and travel to 0. Now my increasing is going to start at 0, and I'm going to continue to travel along my x-axis all the way up to positive infinity. Now in this case, in terms of my constant, I have none. The constant is any place in your graph where you plateau, meaning you would travel along, say, let's say at y equals 2. You would travel along that piece for a certain period of time. That is constant. In this case, we don't have that. We just have increase and decrease. Now, since we've evaluated and identified everything we needed to out of this example, we have completed our problem. Okay. Oh, and the last thing that we want to look at is this actually a function? Now, if you remember, in order to identify if something's a function, you have to look at whether it passes or fails the vertical line test. In this case, if I drop a vertical line anywhere in it, okay, so I could drop a vertical line here, I could drop it here, I could drop it here, I mean anywhere I drop it, I pass my vertical line test. So the biggest thing that we have to look is that yes, f of x being the absolute value of x plus 3 is a function. And the reasoning is because the function passes the vertical line test. Okay, so that is everything that you would need to identify. Alright, now I want to do one more example here, and in this case I have x equals negative y squared. So this is kind of a very interesting function. So the first thing that I would do is I would go ahead and graph it. So here you're going to make an XY table. That is the fastest or easiest thing to do. And in this case we're going to choose y's in order to solve for x. So this is a square. So we're going to go ahead and do negative 2 all the way up to 2. And we have to then solve for x. So at negative 2, we would have negative of the negative 2 squared. Negative 2 squared is 4. Apply the negative, gives you a negative 4. Oh, excuse me. Then we have to move on to the next one. So we're going to have negative of my negative 1 squared. Negative 1 squared is 1. Apply the negative. Then we have negative of 0 squared, which is 0. We have negative of the 1 squared, which is negative 1. And negative of 2 squared, which is negative 4. So we're going to go ahead and graph those so that you have a graph to work with. So if we come here into it, the first thing we have is we have the point 0, 0. So we're going to go ahead and graph that point. We then have the point negative 1, negative 1. So we're going to come over negative and down 1. We then have the point negative 4, negative 2. So 1, 2, 3, 4, 1, 2. We have the point negative 1, 1. So here we're going to come over negative 1 and up 1. We then have negative 4, 2. So 1, 2, 3, 4, 1, 2. And we're going to go ahead and connect these. And what you'll notice is that we have a parabola. But in this case, it is laying down on its side. Now, the first thing again that we want to look at is this a function? So if I were to drop my vertical line, say we drop one right here, what I want you to notice is that we have two places now where we would be crossing that x-axis. So we would cross it, here, and we would cross it here. And in that case, because we have two places where it crosses, what this means is that this is not a function. And the reasoning is because it fails the vertical line test. Now, because it fails the vertical line test, this also means that we do not have to do any of the additional identification. We don't have to find even or odd. We don't need to look at your symmetry. We're not looking at increase, decrease, because the directions that we had said that you only had to find that if the following was a function. Since this one fails, there's nothing else to do other than state that it fails, and more specifically, your reason why. Okay? So there you have, in a snapshot, everything you would need to get started in working with the concepts of finding different properties of functions. So if you have any questions, please let me know. Otherwise, I do hope you enjoyed this video, and I'll see you next time.